Alright, well I just want to kind of quickly capture the moment here. I've got the code working. The tube bias calculation takes place and you can see it in real time on the screen. And I just want to give a little overview of the whole rig here. That's the tube bias probe tied into the Arduino with the alligator clips, and it ties in there, comes down here to the back with this tube. That is the one under test, and I'm going to turn the amp on, and we'll come back here, flip over to the measurement mode. You could see on the bottom row we're seeing 446 volts, and the second reading on the bottom is the cathode current, which is slowly rising as the tube heats up, and the amount of watts dissipated on the right. So across the top, as that's sort of settling down, across the top is the type of tube, and the target dissipation, which is 21 watts. Max dissipation on a 6L6 is 30 watts, so 21 watts being 70% of that. We're running a little bit cold. We're at 406 volts, 42.7.8 milliamps of current. So that equates to 405 times the number of millivolts gives us the wattage, which is 17.2. That's great. Running a twin reverb a little bit cold is fine, and it'll sound great. It's right near the target for the bias. I could turn it up a little bit hotter, but it's probably not necessary. So there it is. The code's working. What I'm really pleased with is the voltages aren't bouncing all over the place, which is an issue I had. I put together an averaging algorithm that seems to have fixed that. Everything lines up pretty well with the voltmeter when I test it. So onward with the project.